Good evening everybody. Welcome to my channel for electromagnetic theory. Today we are going to discuss the energy stored in a magnetic field. So you know that the current through an inductor, we know that it cannot change instantaneously. It will take the time to change, and whenever the current changes, there will be induced EMF. So that induced EMF exactly opposes the applied EMF. So that means the work has to be done, some work has to be done to establish the current in the magnetic field. So in the inductor, that is in fact converted to energy, and which will be stored in that inductor or in the form of in the magnetic field. Now we know that, so that work done is equal to, so energy, we can say energy or work done, that is equal to EI dt, and we know that E is equal to L di by dt, that is the EMF induced in the inductor into I dt. So we can say work done is equal to L di by dt, so it will be L di I di. Now this one is dW, suppose this one is the dW is the work done. Now if we want to find out work done, so we have to take the integration of it. So it will be, let it be from 0 to W, and it will be integration of 0 to Li di, and the limit of I is from 0 to capital I. So that will in fact give you W, that is the work done, is equal to half L, we can take outside as it is a constant, so half L into I square. So this much of joules we can say, because the unit of work done is joules. Now we know that according to the law of conservation of energy, that work done must be equal to energy stored. So we can write in fact energy stored is equal to half into L into I square. So this much joules. Now we know that L is equal to, so you can write further energy stored. So I am writing in short form. So in place of L, I can write N phi by I, where N is the number of turns, phi is the flux, or we can say that is the flux linkage by current. So into I square. Now it will become 1 by 2 N phi by I. So N phi by I or N phi into I. So that will give you energy stored is equal to 1 by 2 N. We know that flux is equal to MMF by reluctance. So MMF is nothing but Ni. I can write Ni divided by S into, so flux is equal to MMF by reluctance into I. So this one will be half, so it will be N square into I square divided by N square, N into N, it will be N square, I square divided by S, right? So this much of joules. So let me wipe out this one. Now energy stored, I can write from this one. So energy stored is equal to 1 by 2 N square I square. We know that reluctance is equal to L by mu A. So L, length divided by mu is the permeability into area. So we can write this one as 1 by 2. So mu A, it will go to the numerator, N square I square mu into A divided by. So this much of joules. Let me completely wipe out this one. So energy stored, I can write is equal to 1 by 2 into mu. Mu is the constant, that is the permeability. So let us take it here. So it will be N square into I square divided by L into A. So it will be, so energy stored, I can write, it will be 1 by 2 mu into N square I square divided by L. Now multiply L in both the numerator and denominator. So this will become energy stored is equal to 1 by 2 mu into N square I square, L into L, it becomes L square into AL is nothing but area into length, it becomes volume. So this one will lead to, the equation leads to 1 by 2 mu into H. We know that Ni by L is equal to H, that is the magnetic field strength or magnetic field intensity, into volume. So this one is the energy stored. In fact, we can write in place of mu, we can write, or in place of, it will be 1 by mu. We know that B is equal to mu H, so H is equal to B by mu. So B is equal to, we know that B is equal to mu H, so in place of H we can write B by mu. So it will become, so energy stored is equal to half mu into H square, so it will be H square, mu into H square into volume. So mu into H square becomes B square by mu square into volume. So mu square gets cancelled. So energy stored is equal to B square by 2 into volume. So this one is the energy stored in the magnetic field or in the inductor. So I can say that what is the energy density? We know that the energy density is given by energy stored per unit volume. So this equation, suppose this one is equation 1. Now this will lead to energy density. We know that energy density is given by energy stored per unit volume. So volume, energy stored per volume. So if we take this one to the left hand side, it will become B square by 2. So this is the expression for the energy density. So exactly what happens, again I am telling you. So that means the work has to be done to establish the current in the magnetic through the inductor. So that work is in fact stored in the inductor. So that is the energy stored in the inductor or in the magnetic field. So this is the expression. In the next class we will be discussing some of the related topics to magnetostatics. So stay tuned. Thank you. Please like, share and subscribe to my channel. Please.